Why do you find a zero force members in a truss? Well, let's first find out how do you find a zero force member in a truss. Well, it's really easy if you know these two cases. Case 1, when any two non-collinear members, for example, members like this, or maybe like this, or maybe like this, they meet at a joint and there's no any external load applied to that joint, then these two members are zero force members. That means these two members do not carry any forces. Case 2, whenever there's any three members meeting at a joint and two of the members are collinear while the third member is non-collinear and there's no any external load applied to that joint, then the third member that is non-collinear to other two members is zero force members, meaning this member does not carry any loads. If we look at the truss shown here, and there's joint C where members BC and CD meet. These are two non-collinear members, and then there's no any external load applied at this point C. Then case 1, member BC and then member CD do not carry any forces, so they are zero force members. We can also verify this by looking at free body diagram at point C. Let's say this is force in FBC and then this is force in FCD. We know that equation of equilibrium, summation of forces in any vertical direction would be 0, considering upward forces to be positive. Then negative FCD would be 0, forces in member CD is 0. Similarly, summation of all the forces in x direction 0 minus FBC equal to 0. This means force in member BC is 0. So if we know this concept, let's look at joint A where there's two non-collinear members at some angle meeting at point A. There's no any external loads, so member AB, member AE are zero force members as well. Now, since we know that AB, AE, BC and CD are zero force members, we don't even need to analyze these members. There's only 1, 2 and 3 members that we need to calculate forces for. Let's look at another example, truss. In this truss there's no any joints where we can imply case 1, but then if we look at case 2, joint D has member CD and DE that are collinear, right? Member forces in CD and then forces in member DE are collinear, while forces in DF, member DF is non-collinear, and then there's no any external load applied to that joint D. So according to case 2, we know member DF would be zero force member. That means this does not carry any load. And if you want to verify, you can even draw force like this and consider a summation of forces in y direction to be 0. Either you can find the vertical and horizontal components of these forces, or you can just consider this direction to be positive. This means that there's no any external load, so force in FD F, that is member DF, would be 0. Now if member DF is a zero force member, then we can again look at member joint F. GF and FE are collinear, while the third member CF are non-collinear meeting at point F. And are there any external loads? No. So this means that the third member that is non-collinear, member CF, is zero force member.